don't think you have to do that. What? Put them all at once. I'm only doing one for you.
What did I tell you to do when you knew it was a sine, cosine, tan problem? What's your first step with the right triangle, Leah? Circle the angle first. So let's do that. Circle 51. Of course, before all of this, you've gone through your head that Pythagorean theorem can't be used here. You have to consider the king of chapter 7 first, which is Pythagorean theorem. I can't do that. I can't do special right triangles because it's not a 45-45 or a 30-60. So all I have left to use is sine, cosine, tangent. Leah, let's continue. You said label. What would I label the H as?
I labeled it as I said X was able to use it, but
Okay.
I took the 21 meters as A.
Adjacent. And the H?
And then I said it was
Opposite. The only things that can be an opposite side or an adjacent side in our problems are the legs. If you get confused with labeling, I always use a capital H for hypotenuse and a lower case h for height. Don't get those confused. What did mathematicians call the O over A fraction? They decided to give it that name, so we're going to use that name. On the sideboard, this will be up here because it's really on your formula sheet. And we're going to talk about that at the very end of class. So this will be up there. What am I looking for, a side or an angle? Side. So I want one of these. I know I'm going to have to do some sort of equation work. If I was doing this, there's no work to it. I just put it in the calculator and I get an answer. So I know I'm going to have to do a little bit of work. I write down that formula. Tangent, angle. I can use the angle symbol. I can use the theta Greek symbol over there. Doesn't really matter. O over A. I told you to put this over 1 to make it a little simpler if you have trouble coordinating your equation manipulation. Then fill it in. Tangent 51 equals H over 21. When you cross multiply, you will get H, and you will get this times this. Put it in this order. Put the 21 first. Put a box around this. Some of you are just churning through the procedures and not really thinking about what's in front of you. The calculator's doing this for you, but what did we say sine, cosine, and tangent are? They're funny names for what? Fractions. But what does the calculator deal with as a fraction? It doesn't show you a fraction. What does it show you? A decimal. So this is just some decimal that the calculator is going to figure out for you. This is 21 times some decimal. And if you put that in your calculator, you will get to the nearest meter, in this case, 26 meters. Does it make sense in the drawing? Let's see. Put it here. What is the other angle that we haven't talked about? We got a right angle here. We got 51 there. What's that other angle? How much is left?
39.
39. I want everybody to think back to chapter 5. In chapter 5 we said big angles are opposite big sides and little angles are opposite little sides. Is the small side opposite the smallest angle?
Yeah.
Is the slightly larger side opposite the slightly larger angle?
Yeah.
So at least it makes sense. We don't have something less than 21. Yes.
I put it in my calculator. I'm gonna get 26.
Did you set your calculator to degrees? Like you should have at the beginning of every class.
Wow.
Press this button, press mode, and what's the third line say?
Radian. Then you switch it over to.
If it says radians, you got to switch it to degrees.
Sorry, on. My scissors. Third pair of slow.
Hey, 29. Wait.
I just need to.
Take mode. Be good day. We're doing 21 times tangent 50.
I got quit.
You should have close.
That's about me. You're the one who took. What do you mean don't take me?
I got quit.
Guess what?
That makes sense. Jenny, I'm being so sorry.
For question 2. Is this the same setup as the previous problem?
Yeah.
Yeah.
Isn't that going to be tangent? So, go ahead. Those of you who did this, what do you get when you do the same procedure as I just did?
Sim.
And would you expect something big or something small? Since I got a small angle here, and what I'm looking for is across from it, it's probably going to be smaller than 100 meters. What do you get? Like 21? So I'm not going to show the work. You know you're going to be setting it up almost exactly the same way, but with those numbers. 12 degrees, 100. Where is the variable for these two problems? Top or bottom? In the equation. Top. That's one type of problem you're going to see where your variable is on the top. If that's the case, it's going to be easy because that variable is going to be multiplying to 1. You don't have to do a whole lot of work. You're multiplying.
There's something I can say.
Circle your angle in number 3. Label your sides. Don't label the empty side. We don't care about it. I see an H. And what is the height?
H.
What did mathematicians call O over H? Sine. This time I'll write it down with sine theta. I can use the angle symbol, I can use the theta symbol. Sine 40 degrees over 1 equals lowercase h over 80. Is this going to be an easy problem because the variable's on the top? Yes, that's what you want to see. 80 times sine 40. I'm getting about 51. Is it less than the hypotenuse? That makes sense. Circle the angle. Do we have the angle?
No.
No. With the sideboard, in the case of an angle, we're not doing this. So don't set up a proportion. You're just doing input, output. But you got to make sure you use that second function, the blue stuff. You just have to determine which inverse you want to use. So label. What is the 15?
H.
Big H for hypotenuse. What is the 10? That's close to the angle, so we call that adjacent. What are mathematicians calling A over H? Cosine, but since we are looking for an angle, I want inverse, which means I want cosine inverse A over H. I plug that in, I'm going to get my angle. do this in blue. That's what it is on your calculator. 10 over 15. To the nearest degree, what do we get?
48.
How much?
48.
48?
48.
48 degrees. Notice the difference in the work. We're just inputting and outputting. Input this, and you get an output on your calculator. Don't set up a proportion, don't cross multiply, it's just input output. Okay. Next page. On your drawing, you have extra stuff. Do you have something written below that?
10 years.
Cross it out. I don't know where it came from. It says it's not on my tab. I'm getting ghost numbers. So cross out the 10 because it's not there. If I'm labeling that, what would you label the x? There's capital H for hypotenuse, and what about the 120? That's, oh, it's over there, it's on the other side, it's opposite. What are we calling O over H?
17.
Are we looking for a side or an angle? Which is a side or an angle? Side. So that means I have to do a little more work. I have to set up the proportion. Sine 63 equal to, but this time where is my variable? It's going to be on the bottom because we have sine angle over H and 120. It means you have to do a little more work because when you cross multiply, x is not alone. You have the sine 63 times the x. Put it in that order. What's the little extra step that we have to do now to get x alone? How do you get rid of anything next to a variable? I gotta divide. So this is the extra step. Some people have already figured out a pattern to these things, and when they do it, they don't even set this up. I don't care what you do on the test. We've already had the quiz. I saw who knew what they were doing and who was making mistakes. Now, if you see x on the bottom, you can jump right to this step. You know you're going to be doing division. Why not just do the division? What is 120 divided by sine 63?
134.
And we want to the nearest, so 135 meters. Does it make sense in the context of the problem? Does it look like it could be the longest side? Yes. Got 120 there, bigger than 120, makes sense. Are you getting the hang of this? Circle, label. If you are not understanding where that A or H is coming from, talk to me at the end of class. At the very end of class today, I'm going to get you started on the next unit. Next unit is mostly reading. You're going to read the very first section in chapter 8, dealing with polygons. Instead of triangles, instead of all the little things that we've been doing, we're expanding it up to quadrilaterals and hexagons, and octagons, etc. What is A and H? What do we call it? Cosine. Am I looking for a side? Yes, so I got to do a little bit of work. Cosine 18 degrees. Some of you are placing the 18 into the fraction. The degree measure goes wherever I have the theta symbol, or in some cases, angle symbol. Doesn't matter what I'm calling it. That's where you're placing the angle. X over 2,500. I consider that to be an easier problem because x is on the top. I got 2,500 times cosine 18. Put a box around cosine 18. Never lose sight of the fact that that's just the number. We're writing it this way because the calculator is going to handle it, but it's some decimal. In fact, do cosine of 18. If you want to check yourself when you're totally done with this test, put in the decimal. What was put in just cosine of 18. This turned out to be 2,378 miles. But what is this? Typically we use 4 decimal places, so we might say that this is equal to 0.9511. Well, go ahead, do 2,500 times 0.9511 and see if you still get 2,378. Verify that your calculator is actually doing what it's supposed to do. Are we getting something close to this? Okay. As long as we round, it's close enough. So realize that that's just a number the calculator is doing for you. It's some number that's a decimal. If it helps you to put that in there, do it. We've got some vocabulary here. Everybody circle this. Angle of depression. It's not really vocabulary because typically all the problems that mention it give you the angle of depression. Draw an arrow from here over to here. That's what we're talking about. Typically you are looking down from someplace. This is a lighthouse and somebody's looking down, and that angle from horizontal down is called the angle of depression. Put another arrow down here and write angle of elevation. You're either going to be given one or the other, but they're the same thing. Why is this degree also 10?
Alternate interior angle.
Alternate interior angles. No excessive celebration. So if you are given one, you can immediately write in the other one up above it, or if you got the top one, you can put it down here. The whole idea is to get something inside the triangle so then you can do one of the problems that we just did. Label now. Circle the 10 degrees that you've just put inside the figure, and label your x and your 25. What's your x? Capital A for adjacent, and 25. Opposite. What is O and A called? Tangent angle over A. Tangent. What did I say the angle was? What am I putting in that spot? 10 degrees. What did I label as O? 25. Where's the variable showing up this time? Bottom. Bottom. So what is going to eventually happen? You're going to divide at some point. You can run through the steps. Tangent multiplies the x, 25 multiplies the 1. So you can do that and do that. But eventually you know that you are going to be dividing by the tangent 10. The tangent 10. This goes away. X will eventually be equal to whatever you get out of that. How much?
142.
Oh, to the nearest meter?
Yeah.
What do we get? 142. Do we like that? Is that confirmed? As far as your test, that'll get you a passing grade. We're going to talk about some details when we go over the blueprint, but SOL, that's what you're going to see. Same with what's down here. We've got our special right triangles. Before we begin, find the 30-degree ones. So jump right to 8 and 9. That's got 30. Why am I finding that? I'm finding that so I can find the short side across from it. Short side. If this is 26, what is this? 13. That's the pattern. If this is 7 radical 3, what's this? 7. 75% of what you're going to see matches up with our models perfectly. But then you get problems like number 10. Number 10, normally we would see a radical over here. What radical are we expecting to see? So actually do it. I'm supposed to take this side and attach a radical 2 to it. That just means that it's equal to that 10. Anytime that the problems turn out to be a little more difficult, you know you're going to have to do some radical division. Or division with radicals. How do I get rid of that?
Divide by radical.
Divide by radical 2. 10 divided by radical 2. The whole point was to get rid of it from that side. That is a perfectly legitimate answer, but do you see it anywhere in your choices?
No.
No. How do you get rid of a radical off the bottom? I got to multiply by the same radical on the top and the bottom. That makes it prettier on the bottom. That's the only reason we're doing this. And how pretty does it get? What's on the bottom? 2. What's on the top? You just mush it together. Got your 10 radical 2. If you can reduce it, go ahead. What's 10 divided by 2? Yep.
In number 8, you didn't find X.
Thank you. So I had to take this, bring it over here, 13 radical 3. And he was sleeping. Thank you.
How do you?
Questions?
No.
Number 11 matches up perfectly to our model. What am I supposed to do with this to get this? What do I attach? So 1, 2, 3 of these follow the pattern perfectly. The one that doesn't, you still actually follow the pattern, but you might have to do some work with the radical and get rid of it off the bottom.
Why is 10 not C?
10 not C. Because that would be a larger number. Do 10 times radical 2 on your calculator. What is that number at? And we want something that's less because that's the hypotenuse. So that's also a way to check yourself. So I just recorded all of that. That's why that red line is around the whole screen.